Hi there. Here we are in Raiders of the Alaments, which we will use to learn how to grab a screenshot and associate it with a saved game. We will then look at how the screenshot can be used when loading the saved game.
Objective completed. New objective available.
If you have watched any of my other videos, you may be puzzled as to why I sound so different. That's because this is not my voice. I have cheated and used a voiceover application, as that is much faster than recording and editing myself. So please settle in and chill out for a gentle ride. If I click the pause button, we go to the pause screen, which has two buttons for saving the game. One for saving and continuing the game. And one for saving and quitting the game, which is what we have just done. In the load game screen, you can see the screenshot taken when the game was saved, as well as the character pick selected by the player for this game. When we load the game, we are starting with the same camera view as shown in the screenshot, which is, of course, the expected behavior.
Monitoring and control systems initializing.
Let's quit the game and go through the screenshot mechanism in this game. As you will see, it is much simpler than you might think. Here we have the HUD. The pause button is in the top right corner, as we saw in the game. This spawns the pause screen as a child of the HUD. The pause screen has the save button and the save and quit button. Going back to the HUD. In the script we have the on pause button pressed function, or method if we're being formal. This is triggered by the pressed signal from the pause button. At the moment, the function plays a click sound, instantiates the pause screen, gives it some information and adds it as a child of the HUD. What we're going to do here is add the statement to capture a screenshot. We need to do this here so that the screenshot is captured before the pause screen appears. Otherwise, all we would get is a screenshot of the pause screen. This does mean that the screenshot is taken every time the pause button is pressed, regardless of whether or not the game will be saved. But the overhead is minimal and does not affect the performance of the core of the game. The first step is to capture the image and assign it to a variable. To do this we use getViewport. .getTexture. .getImage. Simple. This captures everything that is currently visible in the game window. However, I don't want the HUD included and I also want a square image to match the square texture rect in the load game screen. The getRegion method for the image class lets us take any rectangular area from an image. It requires a rect2i. If you look at the documentation, you will see there are several ways of providing parameters to a rect2i. In this case, I have used the pattern where you specify an XY start position, starting from the top left corner of the image, then specify the dimensions of the image area, or region, to keep. The region I am keeping each time an image is captured is 1000 pixels by 1000 pixels. This is the largest region of the image I can keep as a square, while also avoiding any of the HUD elements. The image class also has a method for resizing images. The resize method simply takes new width and height, or X and Y dimensions, and changes the image size accordingly. You can optionally change the interpolation, which defaults to bilinear. I decided not to use this in the end, as the capture images are fairly small and, if they want, players can copy the images to save them for posterity or share on social media, and so on. In the script for the pause overlay screen, we need a variable to hold the image captured by the HUD. In this case, it is the SaveGameImage variable. We also need a function that the HUD script can use to pass the image to the pause overlay screen. This is the setSaveGameImage function. It takes a variable of type image, and assigns the value to the SaveGameImage variable. The final step in the HUD is to pass the captured image to the pause overlay screen. This is done before adding the pause overlay as a child of the HUD. This makes the image available to the pause overlay, before it enters the node tree and executes its ready function. Incidentally, a loaded or captured image is not actually stored in an image class variable. Instead, as with a lot of things in Godot, the variable is a reference to some data held in memory. In this case, that data happens to be an image. Back in the script for the pause overlay screen, notice that the first thing it does, in the ready function, is pause execution of the game with getTree.paused equals true. The pause overlay screen itself is not affected by this, as the process mode is set to always. Before this happens, the HUD has already passed across our captured image via the setSaveGameImage function. We can now associate this image with the saved game, if the player chooses to save the game while the game is paused. In the functions triggered by the save and quit buttons, we have a call to the SaveGame function. At the moment, the SaveGame function displays a saving message, and then calls the function in the game control singleton that saves the game data. You may have noticed that the saving message did not seem to appear. This is because, at the moment, saving the game data happens so fast that the saving message is only displayed for a fraction of a second. This is likely to change as the game grows and there is more data to save each time. If you would like to see a video about the game saving mechanism, please let me know in the comments. Now let's add the statements to the SaveGame function that will save the image alongside the saved game data. In my game, I have decided that the image file name is going to match the file name for the saved game data. There are many different ways to do this. You could, for example, include a timestamp in the file name and then save the resulting file name as part of the saved game data. This would generate a new image file each time the game is saved, instead of overwriting the image each time. Here I am declaring a string variable to contain the file name, which is composed of the current player's profile name, from the profile control singleton, some joining characters, and then the name of the character for the current game, which is taken from the game control singleton. If you want to know more about how I use singletons in my games, please leave a comment, and I will make a video about that too. To save the file to disk, we can use the savePNG method for the image class. I prefer to use the PNG format, as this avoids unpleasant artifacts in the image. This requires the full path to the file, including the PNG file extension. To provide the target directory, I am using the same variable, from the game control singleton, that is used to specify the save location for the game data. Another way to do this might be to have a player preference for image format, say either JPEG or PNG, and then construct the name of the save function in a variable, which would then be passed to the call method to save the image, with the image file name passed with the bind mechanism. Again, if you would like to see how this would be done, please let me know in a comment. The game save directory variable, from the game control singleton, points to the user data directory. This user data directory is automatically created when you run a Godot project, and it is named according to the project name in the project settings. In the Godot editor, we can open the user data directory by going to Project, Open User Data folder. This directory already contains the PNG saved when I demonstrated the save and load functionality at the beginning of the video. Back in the editor, the next step is to open the scene files for loading the game and the saved game buttons. How this works is that the saved game button scene is just a giant button. On the button are two texture rects, one for the character portrait and one for the screenshot. The load game script looks for games saved under the current profile name. One of the giant buttons is instantiated for each saved game that is found. Going back to the load game scene, if we look in the script we can see the point where each button is instantiated. The scene has a scroll container node. Within that is a VBox container. The buttons are added as children of the VBox container. If there are a lot of buttons, the scroll container lets us access the full list of saved games. In the script for the load game scene, notice that some information is passed to a button before it is spawned as a child of the VBox container. This provides the button with the information it needs to display the character portrait, the screenshot, and the text information on the button. Jumping across to the saved game button scene, we can see the function where the button is sent the information from the load game scene. This is then available to the button scene before its ready function executes. It is the ready function where the images and text information are updated on the button. First, the character pick is loaded into the first texture rect. This only needs the two statements here, because all of the character portraits are part of the game's resources. Let's now work through the statements used to load the screenshot captured when saving the game. The first step is to declare a string variable that contains the file spec. In other words, the path to the PNG file, the file name, and the file extension. In this case, the variable is called level pick path. Notice that we are reconstructing the PNG file name from the current player's profile name and the character name, just as we did when saving the PNG. Next, we create a variable of type image, and load the image data from the file spec held in level pick path. We can now use the loaded image to create a new image texture, referenced by the level pick text variable. Lastly, we can apply the image texture to the second texture rect, and then we have our screenshot displayed on the button. As noted before, we only needed 2 steps to load a character portrait. The reason that we need 4 steps to load the screenshot is because it is an external image. That is, it is not part of the base set of resources for the game. However, as you can see, once you know how to load an image, it is pretty straightforward. And here it is in action again, with the screenshot successfully loading on its saved game button, spawned into the load game screen. Lastly, here is a more generic function for loading an image that is not part of the game's resources. This last line of code shows how it is possible to collapse all 4 steps into a single statement. For my purposes, I prefer to keep the steps separate. This is easier to debug if something goes wrong, and it makes very little difference to performance, as this is all taking place in a part of the game where performance is not critical. If I was going to do this, I would still use a variable for the file name, as shown in this last example. To make it fully generic, this function could take the file name and the target texture rect as parameters. This would be useful if you needed to load multiple images into a scene. However, this is not necessary for the button in this scene, as it only needs to load one external image. I hope you enjoyed this and will find the information in this video useful. If you would like to try the prototype of Raiders of the Alaments, click the link below. However, please be aware that the version seen in this video has already moved on from the prototype. Please subscribe if you are interested in more content like this, and please leave a comment if you would like me to further expand on any of the topics touched upon during this video. Thanks for watching, and see you next time.